All right. Good afternoon, everyone. All right, so this is the science department. Okay, so we'll be conducting. So good afternoon, everyone. So we'll be conducting an inquiry cycle today. So today I brought. Oh, first of all, let me share this with you guys. I think you guys are on it. You guys are on it already, so it should say science department, no catch-up for inquiry work. So yeah, me around two. So today I brought some student work. It's one of the labs that we did. So it was trying to find the average atomic mass of an element, and we used candy. So the simulation was I used Skittles, M&Ms, Reese's Pieces, and students had to basically do like a number of calculations and try to figure out like the average mass of that candy activity. And the whole point was to realize whichever candy weighed the most and was most abundant, that was the closest, that was what the actual mass of the candy element should have been. So similarly just to like elements, so for example, like carbon. Do you guys remember isotopes?
Yes.
Okay, right. So we know carbon has 3 isotopes, carbon 12, carbon 13, carbon 14. We know that carbon 12 is the most abundant isotope because it's, we know the mass of carbon is 12 because it's the most abundant isotope. So that this idea was just using candy, a fun way to just simulate that. So as we could see, so if I were to describe a learning target, I would say I will be able to find the average atomic mass of an element using its abundance in nature. How did we practice this skill? This was actually, I guess you could say, an introductory, because we actually didn't talk about how to calculate average atomic mass yet. The whole point was for them to just be able to just observe, really, with the candy, how the whole point was to them, I guess it was I don't know, like an exploratory, I can't find the right words, activity first, and then based on like the results that they got, then we got into, well, how does this relate to elements?
Yeah, so it's like almost like phenomena piece, right?
Yes,
Where
right, exactly.
they're like, learning by discovery,
Yeah.
and then you give it a name after the fact.
Right. I appreciate you putting the name on it.
No, yeah.
Yeah. So you guys could just take a moment to just look at. I have here a student who is considered low. So this I basically did POE, so predictions. Student made predictions. Again, they had a bag of candy. Those are their isotopes: M&M, Skittles, and Reese's. Which of these isotopes do they think would have contributed greatly to the average atomic mass of candium? Candium is the element itself. Their observations was them doing a couple of calculations. As you can see, I placed those calculations for them.
And so the candy represented like the different isotopes.
So
you said?
correct, yes. And then doing those calculations, they were supposed to come up with an average mass. It should have been closest to the Skittles because that's what I purposely made sure there was more of, and also Skittles are bigger in nature, so that makes sense, and Skittles were more abundant, and they also had the highest mass. Then the average mass of the candy sample should have been closest to the Skittles. So as you can see, for the low student, the math is not mathing. So therefore they weren't able to come up with a good explanation. And yeah, you guys can just take a moment to look at the difference between the low and the high. And feel free to ask any questions or clarifying questions.
This was like one period?
No, we did it over 2 periods. So the first period they collected data, and then the second period, which was the next day, then they were working on their explanation, their calculations and their explanations. So it was only like the high student who really got the calculations correctly as far as, and I guess that's why they were able to also write a good explanation.
Do you think if you had done it with, since you're doing it as an exploration,
Right.
more inquiry based, maybe do it using a weighted average, like their grades?
Oh Yes, yes, yes.
I find that when I was teaching this, I started off by doing like grades for them, showing them how grades are calculated, to give them an idea of what it means to have a weighted average, and also for them to understand what's happening with their actual grade, because a lot of them don't understand why one homework assignment does not automatically make you pass if homework is only 10% of your grade, for example.
I definitely agree with that too, because I forgot what it was earlier this year, but I did find the average. And surprisingly, a lot of kids knew how to find the average.
They added up everything.
But most of them didn't know what it even meant. And like, there were some students who didn't know it, or they did it incorrectly, and then the number was like lower than all the
Yeah,
numbers, and
and
you're
they
like,
don't-
this is it. I'm like,
Yeah.
could this feasibly be it? And it was like a whole reteach thing at that point.
Right. Yeah, I usually, when I do introduce average atomic mass, I do it in terms of their grade, because I find that it makes more sense to them, and it kind of, kills two birds with one stone. Now you know how you grade in class,
Yeah.
and now you have some type of background knowledge to apply to this activity. And I probably would have done this at the end,
Okay.
because I do beans instead of candy,
Mhm.
because they eat the candy. But beans, I find that they don't eat, so we had beanium, even though I've had a few try. I've had a few like.
Yeah,
I feel like it's just less issues to deal with.
Right, I usually.
I also write that allergies too, candy.
So I use the beans, and it's a lot more, right? So that way they can have, they can see what they're doing with the calculations when they have a larger sample. I feel like it's easier to mess up when I only have like 50 pieces.
Right, and you're right, yeah, the calculations were very close. Yeah.
Right, so I would.
Were they given that, sorry to cut you off, that average mass, I see it was handwritten in, that was written before they got the copy, or was that for us?
No, sorry,
The formula.
the formula, no, they needed the formula.
So that they had.
Yes,
Okay.
that was what they had. Yeah,
Good,
that was what they had, yeah. But Ms. Parker brings up a very good point, because the funny thing is I did use that example, but it was like a by the way. So I think like actually doing it as an activity, like this is how your actual averages is weighted. So gym doesn't weigh as much as probably an AP class or something like that. So I think that was.
You don't even have to get that fancy.
Oh, okay,
It's
that's
a
good.
class,
Right.
as opposed to their transcript, like
Mhm.
I do it towards, I do it like 3 different examples of students, and I show them how, because exams count more,
Yeah.
this kid failed everything else but passed all these exams, they still ended up with a 70, versus a kid who's done all their homework and classwork, and it's great, but they failed every single exam, haven't done a lab, here's your grade. Because I don't think it makes sense to them that certain things count more than others.
It doesn't with the new reading policy, right, everything's.
But even then, if you
Make
have.
it more points.
Right, but then
Yeah.
if you had 10 homework assignments versus 3 labs, missing 1 lab,
Correct.
it's gonna hurt
Mhm.
more than missing 1 homework
Correct.
assignment.
Mhm.
So if you're going to focus on making up something, make up the lab.
Or make up the
that's-
100-point assignment versus the 20-point
Right.
assignment, or those
So I-
kinds of.
No, that does make sense.
That's usually what I do for day-to-day too.
Makes sense.
I go over, like, this is what you got for first marking period, second marking period.
Mhm.
Now, what grade you wanted to get?
Mhm.
Let's see if that's possible.
Mhm.
Let's do the math. Let's see if that's possible.
Any other feedback or suggestions?
I like the rubric. The rubric's simple enough for the students, I think, reflect on and know what they're gonna get ahead of time. And it's like very clear, especially for like the explanation portion. So I think that's beneficial for the students.
Did you, like, was there additional data sheet, I know you said they had collected data prior, like, was there a different place for them to like write down where they showed their work?
Oh, no,
Was
just
there
here.
math calculations?
No, just here, just here. And then after this, we just did more practice with actual elements, because that was the point, yeah. So this was like the everyday example, but, yeah. make it
Yeah,
like
because I'm
everyday.
noticing like the one that didn't get the right calculation, she was showing it for work, and maybe that's also. Do you give them points like for showing work or no?
So in the calculations, yeah, in the rubric, I do that a lot. So
Okay.
if you see, yep, students did not show me calculations,
Got
students
it.
show calculations.
Yeah, because that's something I noticed, like the AP exam for science, they earn a point for their setup and
Yeah,
showing the work,
correct,
and
correct,
they earn a point for
Correct.
getting the right answer.
correct.
So I think that like almost like conditioning them to
give credit for correct answer without any work.
Sure.
If it's math.
Yeah.
Like if you had to perform a calculation, I need to see it. If you just show me what the calculator gave you, I don't want it. I want to see what you plugged in, and then you can show me what you got after. But I think it's good practice for them to see it. And another thing that I did with this was I set up the table where as they collected the information, they literally just went across to do the math and then added everything down to get their final answer. So it was a way to remind them, okay, this is what you need to do. First step is for you to get the total mass, and then figure out what it is for each one. What's the percentage? Like it was step by step. So it was really hard for them to make a mistake because they just kept following the table every time. So by the time they were done with all the different isotopes, now at the bottom I said plus at the last one, and then they had to add everything up to get the final answer. And then I asked them to check it based on the relative abundance. Like, so 85% made 10 grams, right? Your answer is 2. Does that make sense?
Yes.
Okay, so go back and let's find where you made the mistake. And it's usually with the percentage.
Yep.
They forget to divide, when they're doing their calculations, they forget to divide by 100. And they get numbers that are really large. Like the kid that kept getting 99, all
yeah.
those kids,
Yeah.
they forgot to divide by 100, that's it.
Yeah.
So they don't know that in the calculator, you can put 35%, but you need to press the percent button so the calculator knows to do 0.35. So, yeah, I usually make them figure out, because I just like to make them work a little harder. The decimal fraction, I always make them change the relative abundance into the decimal fraction. Because a lot of times on the regions, especially with average atomic mass, they don't even ask them to solve it.
Yeah, they just
Yeah.
They actually set it up.
Mhm.
So if you make that mistake with the percentage and you forget to either write percent or to divide by 100, you just lost the point for nothing. When you didn't even have to plug anything in, you just have to set it up and show how you solve it. So I would definitely make have their work more visible. I know you're trying to say something, but it fit perfectly in here. I see it. But maybe we give them an extra page just to get their life.
That's
And then
fine.
maybe also, did you do like the M&M's one together? Like, could you scaffold it possibly further where they have like one that you did as a group?
No,
That's when you model.
Yeah,
No.
because that might be another thing that might just be helpful in like doing one of the calculations. I know like my kids, when I tell them
I
math,
see what you mean.
Yeah.
it's like,
Right.
Unless you do one of them.
Yeah.
correct. So like sometimes like if it's like a multi-step, like I'll do the first example all together.
What
And
grade
then
are these kids, 10?
Ninth grade, actually. I just got 2 or 3. I have a couple of.
Okay, because
I think the.
Yeah, I actually had some
that.
that's-
Right?
Manesha's in ninth grade too.
Okay.
she's in 10th, I mean, because you have to remember these are the COVID kids.
So they probably didn't have those
Math,
foundational
So
skills.
they
Right.
were really low in math, like my sophomores for physics, I said, what's 1 divided by 4/3? And everybody was like, what are you talking about, can you even do that? So it took a lot of, like, we're working on dimensional analysis, and physics has turned into a math class, because they just don't understand basic math. They don't have that foundation. So with the 10th graders, the 9th graders, yeah, they need a lot of support.
Yeah.
They need a lot of math support.
Honestly,
They all, yeah, no. But those COVID kids, for real, it's bad.
Yeah.
It's really bad.
So thank you guys. I really appreciate your input on this inquiry work. I think the next person that's going to bring work is Ms. James.
okay, for next month.
Yes, for next week Monday, non-department meeting. Yeah,
Okay.
really appreciate it.